The biggest planet in the solar system is not just a gas giant. Jupiter even hides the formation patterns of the solar system itself and the mysteries of the processes that occur on Earth. Hello guys! That's why astronomers are eager to learn as much as possible about Jupiter. Guys, welcome to our channel. For those interested in this giant planet, get ready. We're going to embark together now on this journey through space. The climate of Jupiter. We always pay attention to the weather when we leave the house. We decide whether we should wear warm clothes or take a raincoat. Astronomers also study the climate of Jupiter carefully. Are they planning to spend vacation in Jupiter? Since the beginning of one of these investigations in 1978, scientists have collected temperature data in various parts of Jupiter. And in 2022, the results of more than 3 years of Jupiter observations were released. And here are the results. Jupiter has no distinct seasons. This is because while the Earth's axis is tilted at 23.4 degrees, Jupiter's rotation axis is tilted only 3 degrees. Therefore, scientists did not expect the temperature to vary in regular cycles. However, the temperature really varies. In addition, the period in which the temperature in Jupiter's atmosphere changes does not depend on known cycles, such as seasons and others. The biggest surprise is that the temperature variations are synchronized throughout Jupiter's surface. When the temperature rises in one place, it decreases at the same latitude in the other hemisphere. Astronomers have not yet discovered why this happens. Snow on Jupiter. On August 5, 2011, the Atlas V rocket launched the Juno space probe on a long journey. About 5 years later, the Juno arrived at Jupiter. The probe directed its focus to the planet, doing research on its magnetosphere, atmosphere, and internal structure. In 2020, the mission was extended for another 5 years, but the Juno has already collected a significant amount of valuable information about this gas giant, deepening our understanding of Jupiter and bringing new puzzles. Although there are other astronomical observation instruments aimed at Jupiter, the Juno not only provides an amazing amount of data, but it also stimulates our imagination. On May 19, 2017, the probe captured images of extremely cold white clouds at Jupiter's altitudes, composed of ammonia and water ice. Researchers believe that precipitation in Jupiter occurs from these clouds. We can't be sure if it's snow or hail, but according to Scott Botten of the Southwest Research Institute in San Antonio, it is more preferable to consider as snow. And you, what do you think? Leave your opinion here in the comments. The core of Jupiter. Before the start of the Juno journey around Jupiter, it was believed that the planet had a compact, high-density core with a mass of 5 to 20 times that of Earth. This core is enveloped by a mantle of metallic hydrogen and the envelope of helium hydrogen. However, when the Juno began to measure Jupiter's gravitational field, it became evident that there were errors in conventional theories. So the scientists proposed a new model. In this model, the core occupies almost half of Jupiter's radius, deriving the concept of a compact core that was previously considered the basis of conventional theory. Heavy elements do not form a homogeneous solid core. Instead, they dissolve unevenly in the metallic hydrogen, increasing the concentration as they approach the center of Jupiter. Scientists have not yet reached a conclusion about how planets of this type were formed. Aurora. The auroras are incredibly beautiful phenomena and can be observed not only on Earth, but also on Jupiter. In 1979, the Voyager 1 probe detected light over the North Pole of Jupiter for the first time, but many details are still shrouded in mystery. The auroras on Earth are caused by the influence of the solar wind, but Jupiter's auroras can be even more complex. This is because Jupiter's magnetic field is much stronger than Earth's, and the distance from the Sun is also greater. On Earth, charged particles of the solar wind move along the magnetic lines, exciting the atoms of nitrogen and oxygen in the atmosphere, resulting in bright colors of red, green, and violet. On the other hand, in Jupiter, the auroras are always occurring. This is because the flow of charged particles is generated not only by sunlight, but also by Jupiter's own planetary system. The Io loop, as a result of an intense volcanic activity, expels large amounts of sulfur oxide. These gases ionize and involve Jupiter in a plasma disk composed of a gas toroidal, electrons, protons and ions of sulfur and oxygen. This immense plasma laboratory that rotates with the planet has stimulated the curiosity of scientists. Jupiter's auroras emit electromagnetic spectrum in all ranges and have a characteristic pulsation. In 2021, the cause of the X-ray pulsations of the auroras was clarified. Scientists have discovered that when analyzing Juno's data and the XMM Newton telescope, the magnetic field that rotates along with Jupiter collides with the solar wind, generating electromagnetic waves of ion cyclotron in the process, which results in the pulsations of the auroras in the X-ray band. Connected satellites. The intensity and behavior of the auroras seem to be related not only to the solar wind, but also to Jupiter's moons. The launch of the Juno space probe not only confirmed these assumptions, but also raised new questions for scientists. In 2016, Juno was able to capture fantastic images of the auroras over the south pole of Jupiter. This is something that is difficult to observe from Earth. However, Juno was launched with the purpose of making the invisible visible. Astronomers compared the aurora data in the north and south poles captured by Juno and found that their pulsations were not synchronized. This lack of synchrony is very different from the auroras on Earth. In the south pole of Jupiter, X-ray high-energy pulses occur in an 11-minute cycle. On the other hand, in the North Pole, the intensity of the auroras varied regularly regardless of those in the South Pole. At the time, existing theories could not explain why the pulsations of the auroras were not synchronized. Therefore, researchers began to consider the possibility that there was some additional factor that would locally affect the conditions in Jupiter's magnetosphere. This factor may be the planet's moons. Io, Europa and Ganymede left their own visible marks. These are the points of aurora. To investigate this relationship, Juno flew through the electron beam going from Io to Jupiter and measured the parameters of the electron rain. At the same time, scientists recorded the changes in the points of Jupiter's aurora that are connected to Io by an invisible radius. As a result, they discovered that the addition of magnetic stimuli to the flow of electrons caused variations in the intensity of the auroras in the ultraviolet band. In 2022, a similar experiment was carried out in Ganymede. Researchers hoped to find a similar relationship, but they did not come to this discovery. The investigation of this phenomenon is another challenge attributed to Juno and the future mission of OSSI. New Jupiter's moons. Jupiter is not interesting just for its own mysteries. The many moons of Jupiter also fascinate astronomers with their own enigmas. For example, Ganymede is the largest moon in the solar system, and Europe has the possibility of housing oceans of water, making them incredibly attractive. The first 4 moons of Jupiter were observed by Galileo Galilei in 1610. This happened in 1610. However, today's scientists have much more powerful and advanced equipment than those used by the Italian astronomer. As a result, new moons are regularly discovered. Only in January 2023, 12 new moons were added to the catalog. This raised the number of Jupiter's moons to 92, making it the leader in the number of moons in the solar system. Meanwhile, Saturn, which was the leader with 83 confirmed moons, sighed enviously in the depths of the solar system. In February, 3 more new moons joined Jupiter's assets. Although the dominance of this gas giant has seemed unquestionable. In May, the International Astronomical Union recorded dozens of new moons of Saturn. And that raised the number of moons of Saturn to 146. The competition is still on. The question that remains is, how will Jupiter respond to all this? Jupiter's abyss. Jupiter's greatest highlight, the Great Red Spot. This powerful anticyclone, which stretches for 16,000 kilometers, has been observed continuously for 350 years. But there are many other points of interest in Jupiter's atmosphere. An example is Jupiter's abyss, captured by Juno on May 29, 2019. This is a very rare red spot with bright edges and a dark center. NASA is not sure of its true identity, but it is believed to be a hole in the atmosphere that extends into deeper areas. Don't you think it looks like a red spot that forms when you drain water from a bathtub? Well folks, today's video ends here. Thank you all for watching until the end. I hope you found the video interesting. And if you liked it, please click like and press the bell button to be notified about new videos and new content here on our channel. In addition, please share this video on your social networks. As a return, we will prepare incredible content like this for you. Now let's start preparing for the next video. So it's time for us to say goodbye. A big hug and see you soon here on the Wikivedia Plus channel. Until then, bye.